assignment. This is assignment number 10 solutions. All the numericals are based on degree of association or degree of dissociation, Van't Hoff factor. I've written two relations on the board. This is D for dissociation, alpha is equal to I minus 1 divided by M minus 1. A for association, alpha is equal to I minus 1 divided by 1 divided by M minus 1. In the first relation, M is how many ions are produced by one molecule of the compound. In the second equation, M means how many molecules combine together to form aggregate, right? So we start with numericals. First numerical. Phenol forms dimers. It means this value for M will be 2 in this case. This is for association, right? When dissolved in benzene, a solution containing 5 grams of phenol dissolved in 250 grams of benzene showed a depression freezing point of 0.64. So depression is 0.64. In all these numericals, we'll calculate the value of I. Then I will be substituted in one of these two and calculate alpha. In case we have to calculate degree of association or dissociation in percentage, after calculating alpha, multiply by 100. That is our answer. In case not asked in percentage, then leave the answer at alpha. So depression is equal to I into Kf. Kf is 5.12 into molality will be how many grams? 5 grams divided by molecular weight into 1000 divided by this is how much? 250 grams of benzene. From this, calculate the value of I. I will be 0.5875. Please calculate the value of I up to 4th decimal place. Otherwise, this will lead to a lot of difference in the answer. Now, this value will be substituted in A equation and the value of M will be 2 because it forms dimer. Rest you have to substitute and calculate the value of alpha. Second, observe molecular weight of benzoic acid. First of all, this is not benzoic acid. You can say observe molecular weight of a solute, right? Of a solute determined on the basis of colligative properties 212, while normal molecular weight is 185.5. Calculate percentage association and it dimerizes, that is given towards the end. Now, in this case, I is equal to normal molecular weight, that is 185.5 divided by observed molecular weight. I gave you 3 relations for alpha. One of them I'm using to calculate the value of I. So this I will be 0.875. Now this will be substituted in association and it dimerizes. Dimerizes means value of M will be 2. This will be 2 and this will be in association. Numerical number 3. A decimolar solution. Decimolar means molarity is 0.1. A decimolar solution of an ionic solute AB2. Ionic solute AB2. It means one molecule will give 3 ions. In this case, value of M will be 3, right? Exerts an osmotic pressure of 4.6 atm at 28.2 degrees centigrade. Calculate percentage dissociation of solute. Now, in this case, pi is 4.6 is equal to I. M decimolar is 0.1 molar, R 0.0821, and temperature, please you convert yourself on Kelvin scale and substitute. When you calculate, I will come out to 1.8602. This value of I will go in equation for dissociation and the value of M will be 3 as I told you because AB3 molecule will give 3 ions. Fourth, a 0.01 molar aqueous solution of K3 FeCN6. This is potassium ferricyanide. Let me tell you about this. K3 FeCN6. There's a complete chapter on this type of compounds in your syllabus. These are called coordination compounds. In coordination compounds, this part, which is written within square bracket, this will not split into ions. This will be one ion and these will be three potassium ions. It means when dissolved in water, this will form total 4 ions, right? So in this case, a value of M will be 4. Now, 0.01 molar aqueous solution of this compound freezes at this temperature. Calculate percentage dissociation. Kf is 1.86. So depression is 0.038 is equal to I. Kf is 1.86. Molality is 0.01. Calculate the value of I. This will come out to 2.043. This will go in dissociation and value of M will be 3 plus 1, 4 ions. Since you have to calculate percentage, that I already told you, after calculating alpha, multiply by 100. Fifth, a 400 cc solution containing 6.4 grams of solute X exerts an osmotic pressure of 2 atm at 47. Calculate percentage association. It trimerizes in the solution. Now say pi is 2 atmospheres, volume is 400 cc means 0.4 liter is equal to I. We have to calculate number of moles will be 6.4 grams divided by molecular weight. How much? 128 into R into temperature. Temperature is 47, 320 Kelvin. Calculate the value of I. This I will come out to 0.609. This will go in this equation for association. In the numerical, it is given the solute forms trimers in the solution. Value of M is 3. Rest you can calculate. Numerical number 6. Vapor pressure of water decreases from this to this when 10.4 grams of a non-volatile ionic solute AB2 is dissolved in 180 grams of water. Let me convert it into moles. Number of moles of solute will be 10.4 grams divided by molecular weight 0.05. Number of moles of solvent, that is water. I'm directly writing 180 grams of water will be 10 moles of water. Now, P naught minus vapor pressure of solution 158 divided by P naught is equal to I into chi B. Mole fraction of solute will be 0.05 divided by total 10.05. Value of I will come out to 2.5125. This value of I will be substituted in equation for dissociation. Value of M will be 3 because according to the formula, one molecule will split into 3 ions. Numerical number 7. 10 cc of acetic acid, density this much, is dissolved in 800 grams of water. Calculate degree of dissociation of acid. If a freezing point is minus 0.71, means depression is 0.71, Kf is given. So depression is 0.71 is equal to I, Kf 1.86 into molality. Now see the molality part. We are given 10 cc of acetic acid and density is 1.05. Right? 10 cc into density is weight of acetic acid, that is solute. Divide by molecular weight into 1000 divided by weight of water is 800 grams of water. Calculate I. I will come out to, this is numerical number 7. Yes, this will be 0.0 sorry, 1.745. This is I. Now this will go in dissociation. Can you tell me what's the value of M for acetic acid? Quick.
2.
2, because one molecule will give two ions, acetate ion and hydrogen ion. M will be 2. Last numerical. 8.32 grams of solute dissolved in 200 grams of water is so many percent dissociated and elevates boiling point of water by 0.24 degrees centigrade. Predict molecular state of the solute. Kb is given. Now, in this case, elevation is 0.24 is equal to I Kb M. Molality will be weight divided by molecular weight 208 into 1000 divided by weight of water 200. Calculate I. This will come out to 2.3077. We have to calculate, predict the molecular state. Means we have to find out whether there is association or dissociation. In case there is dissociation, then one molecule gives how many ions? In case there is association, then it forms a dimer or trimer or tetramer that we have to predict. So we have to calculate the value of I. Alpha is given. Alpha is 65.385%. If you remember, I told you alpha will always be less than 1. So this was given in terms of percentage. So alpha is 65.385 divided by 100 is equal to I minus 1 divided by M. Wait. M we have to calculate. I we have calculated. This is I 2.3077 minus 1. Now from this calculate the value of M. This will come out to 3. MS3 means one molecule splits into 3 ions. That is the molecular state. Theoretical question number 1. What is the effect of decrease in atmospheric pressure on boiling point of the substance? We already taken up this one in some other assignment. As atmospheric pressure decreases, according to the definition of boiling point of solvent will also decrease. Second, an aqueous solution of urea boils at 100.6 degrees centigrade. Predict boiling point of an aqueous solution of glucose of same molality as urea. See, for urea and glucose, I factor is same, that is 1. Molality is same. It means elevation in boiling point will also be same. So this second solution will also boil at 100.6 degrees centigrade, same boiling point. How does melting point of a substance give an idea about its purity? Now, this is a typical question. See, melting point is nothing but freezing point. Melting point is equal to freezing point. You have studied the topic depression in freezing point. It means if some impurity is present, solute is what? Nothing but impurity in the solvent. If some impurity is present, then freezing point, that is melting point, will be depressed, it will be lowered. So the answer is that if melting point of the given substance is less than the actual value, then it is impure. And in case its melting point is equal to the exact melting point, then it is a pure substance, right? So these were questions of the